Today our lesson is on exponential growth models and exponential decay models because, believe it or not, exponential relationships are all around us and affect our lives. The first one we're going to look at is the exponential growth model, and the equation is written for you right here. So write this part down and I'll explain what each of the parts mean. You remember back to your basic exponential equations, and they were y equals a times b to the power of x, where a was your initial value. Well, notice in the exponential growth model, a is still your initial value. B used to be your growth factor or decay factor, but we're talking about growth. So exponential growth factor. Now this entire quantity, look at this arrow, this entire part, 1 plus r, is your growth factor. And all it did was replace the b. So notice b got replaced with 1 plus r. The exponent t here in red is a time period when in general it's just a variable x. So nothing has really changed here except that b, the growth factor, was replaced with 1 plus r. Now inside that parenthesis, the r stands for the growth rate, and that rate is usually a percentage. And when you see the percentages given to you in these word problems, you need to convert to a decimal. And you do that by dividing by 100. So just keep in mind that your percentages need to convert into decimals in order to use them in this equation. Now it says over here on the right what some of these exponential growth models are used for. Population growth. Population grows exponentially. So we can predict populations of cities or towns or countries by using an exponential growth model like this one. Money grows with an exponential growth model. So we're going to look at the compound interest equation today and calculate how much interest you would earn in a bank account. Read this compound interest problem. So your parents gave you $1,500, and the bank, in order to use your money to lend to other people, will pay you what is called interest. Interest is money the bank pays you to use your money to lend to other people. The bank charges the people they're lending the money to an interest rate as well. So they're being charged to borrow your money. So the bank charges their customers a certain amount, and then the bank will take a profit for itself. And another amount, the leftover amount, they'll pay you. So it can pay to put money in a bank. Suppose your parents deposited that $1,500 and the bank said they're going to pay you 6.5 interest compounded annually. That means they're going to pay you interest one time a year. We're supposed to find the account balance after 18 years. So this is an exponential growth model idea, and here's our basic exponential function. And we know now that all we need to do is replace that b with 1 plus r, and instead of an x, I'm going to use the variable t to represent time. So we're going to need to figure out what a is, what r is, and what t is in the word problem. Remember, a is your initial value, so how much money did you initially put in the bank? Well, that's the $1,500 from the parents. And the account pays you 6.5% interest. And remember, you can't use the percent. You need to use the decimal form. So you take your 6.5% and you need to divide it by 100, which means the rate at which they're going to pay you is 0.065. And then the time is how much time is going to go by where your interest is being compounded annually, and that is 18 years. So now that you picked out the important information from the equation, you simply just substitute it in to this interest equation, which is really just an exponential growth model. So my a, will be replaced with 1,500 The 1 will always be there. It really represents 100%. 0.65 was my rate of interest, and 18 years is the amount that we're going to calculate for. So you just simply put this into your calculator, and the important thing is to remember your order of operations. You're going to want to do this calculation first, because that's your parentheses, then your exponent, then your multiplication. And the final answer you should come up with is $4,659.98 that your money grew to in 18 years. It's important you practice this problem so you make sure that you're actually using your calculator properly. So now let's look into the exponential decay model. Here's that formula. So let's take a look at it. Remember, your basic exponential function looked like this. And you will notice that the exponential decay model is the same equation as the exponential growth model. The only difference is now this parenthesis has a negative sign in it. And this whole quantity here is called a decay factor instead of a growth factor. And you should know this vocabulary. R last time was called a growth rate, and now it's called a decay rate. And in general, what it means is something is going down by a certain factor B. Things in real life that follow exponential decay models, and it was like milk consumption in the U.S. is going down, so we'll look at a problem involving that. Chemistry half-lives, that radioactive idea, is an exponential decay model. Anything you buy that depreciates in value, such as a car, or maybe a video game. Those kind of things depreciate in value. So let's look at an exponential decay model problem. And here's an example of one. Go ahead and read this problem. Take 20 seconds or so. So here we're given some important numbers. The important word to pick out is that milk consumption is decreasing, so that's kind of a clue that you're using exponential decay model. And so let's pick out our important numbers that we will need to fit into the exponential decay model, which is rewritten like this, with a t and then this replacing b. So we're told from the problem that the initial consumption was 16.5 gallons of milk per year for each person. Then they tell us that that amount is decreasing by 4.1% each year. So converted into a decimal by dividing by 100, that's 0.041. And then they're asking us, since 1980, how much does a person drink now? You can predict that. So we're going to have to look at the time since 1980. And at the time of this video being made, it's 2016. So 1980 to 2000 would be 20 years, and now we're 2016. So we're looking at 36 years of declining milk consumption. So now that we have all of our important numbers, go ahead and substitute those into your model. And we're looking at 36 years since 1980. Again, with your calculator, watch your order of operations. This number inside the parenthesis gives you 0.959 to the power of 36. And then when you do the order of operations on your calculator, you will end up with and I'll round it, 7 gallons per person, which is kind of interesting how much that has decreased, isn't it? 16.5 gallons per person down to 3.7 gallons per person. Make sure you're drinking enough milk. Alright, here's 2 guided practice problems I definitely need you to try. Make sure you are thinking about, is this a growth situation or a decay situation? Usually words like increased and decreased might be really good indicators of what you're doing. So pause the video and try to set up your equations. Remember to use decimals, and come back when you're done to check them. And here are those final results. This first example wanted you to write a model, and so when it asks you to write a model, that means like generic. That's why I put the T in here. It's okay if you skipped right to the equation and put the 20 in. I'm okay with that, as long as you found it to be very close to 41,800. Okay, thanks for watching this video. I hope you use this equation wisely and learn to save your money so that you get paid by the bank.